Tsunamis are some of the most destructive natural phenomena that our planet has to offer. And in this video, we're going to explain how they occur. But before we do that, make sure you subscribe for more videos about the amazing science that happens around us every day. Tsunamis are a series of ocean waves caused by a large and sudden displacement of the water. Unlike regular wind-generated waves that only have a small impact on the surface of the ocean, tsunamis can be hundreds of meters high and cause devastating damage many kilometers inland from the coast. So what actually causes these giant waves? The word tsunami actually means harbor wave in Japanese, which is a pretty fitting name because they typically cause massive damage to harbors and coastal cities. The first written record of a tsunami comes from 1755 when Lisbon, Portugal, was hit by a massive earthquake that generated a wave that inundated the city. This event inspired the famous painting The Great Wave off Kanagawa by Japanese artist Katsushika Hokusai. Tsunamis were largely a mystery to scientists until the 1960 Chilean tsunami, which was recorded by modern instruments and allowed researchers to gain a better understanding of these mysterious waves. While people had been aware of tsunamis for centuries, it wasn't until this event that scientists began to unravel the true cause of these destructive forces of nature. Since then, thanks to satellites and other advanced technology, we have learned a lot about the causes and behavior of tsunamis. And in this video, we will explore everything that goes into making one of these gigantic waves. So what causes tsunamis? In general, anything that disturbs the ocean enough to displace a large amount of water can cause a tsunami. While they are sometimes associated with earthquakes, only about 25% of all tsunamis are triggered by earthquakes. Earthquakes that happen under the sea can cause the seafloor to suddenly rise or fall. If this movement happens vertically and is big enough, it can displace enough water to create a tsunami. The vertical movement can raise or lower large areas of the seafloor, causing the water above it to do the same thing. When the seafloor drops down, the water above it has nowhere to go except up, and this sudden upward movement creates the initial wave of the tsunami. Earthquakes that cause tsunamis are known as seismic tsunamis and can be megathrust earthquakes that occur along major fault lines like the infamous 2004 Indian Ocean tsunami, which was caused by a 9.1 magnitude megathrust earthquake off the coast of Sumatra, Indonesia. Other tsunamis are caused by a volcanic eruption, such as the 1883 Krakatoa explosion in Indonesia, which generated a wave that reportedly killed over 36,000 people. Undersea volcanic eruptions can cause a violent release of energy that displaces a huge volume of water and sends waves crashing towards the shore. On land, volcanic eruptions can also trigger landslides that flow into a lake or river and cause a wave to emanate outward. If the landslide enters the water at an angle, it can even generate a tsunami as it does so. Landslides can also be caused by earthquakes, adding another pathway for these massive waves to form. In fact, 50% of all tsunamis are caused by landslides. These can occur when entire hillsides collapse into a body of water, or when rocks and soil are washed away by heavy rainfall. In 1958, a landslide in Alaska caused a wave that was recorded as being 62 meters high, which is the largest wave ever recorded. Tsunamis can also be caused by meteorite impacts. While these are extremely rare, when a large space rock enters the ocean, it can displace enough water to cause a tsunami. For example, the 2013 Chelyabinsk meteor that exploded over Russia was estimated to have generated a small tsunami in Lake Chelyabinsk. Finally, tsunamis can also be caused by human activity. In 1970, a massive landslide dam broke in the western highlands of Papua New Guinea, releasing a wall of water that killed over 5,000 people. In 2006, a wave generated by a tugboat towing a barge in the Gulf of Mexico caused significant damage to port facilities in Mobile, Alabama. And during World War II, a German submarine sank after striking an American ship, causing a small tsunami that damaged buildings and roads near the harbor. As you can tell, there are many ways that a tsunami can be created. But no matter how they start, all tsunamis share some common characteristics. Tsunamis have very long wavelengths, which is the distance between the peaks of two adjacent waves. Because of this long wavelength, they move very fast, often exceeding 800 kilometers per hour in deep water. As they approach shallow coastal waters, their speed decreases and their height increases due to a process called shoaling. The most important factor affecting the run-up of a tsunami on land is the local bathymetry, or the shape of the seafloor. If a tsunami encounters a coastline at an angle, it can be deflected and pushed further inland. In some cases, tsunamis have traveled more than 10 kilometers inland. This is why it is crucial for coastal communities to understand the potential impact of a tsunami and to have proper warning systems in place to evacuate in the event of an impending wave. Tsunamis can be incredibly hard to spot in the open ocean, where they typically have a small amplitude or height compared to their long wavelength, which makes them look like a small ripple on the surface of the water. This is why most ocean-going ships don't even feel the waves generated by tsunamis, even though they can be quite destructive when they hit the shore. When a tsunami approaches the shore, its wave height can increase dramatically, causing a rapid and devastating inundation of coastal areas. Tsunamis typically consist of a series of waves that arrive at different times, meaning that the first wave may not be the largest. In fact, there may be a lull of several hours between the first and second wave, making it even more important to stay vigilant and follow evacuation orders. Now that you know how they're formed, let's take a look at some of the deadliest tsunamis in history. The most recent and deadliest tsunami occurred in 2022, when a 7.6 magnitude earthquake struck off the coast of the Indonesian island of Java, triggering a small tsunami that killed at least 443 people. The waves reached heights of up to 1.7 meters, inundating coastal areas and damaging thousands of homes and buildings. One of the deadliest tsunamis in recent memory is the 2004 Indian Ocean tsunami, which was triggered by a 9.1 magnitude earthquake off the coast of Sumatra, Indonesia. The tsunami waves spread across the Indian Ocean, hitting 14 countries and killing an estimated 898 people. The countries hardest hit were Indonesia, Sri Lanka, India, and Thailand. The total cost of the disaster was estimated to be over $10 billion, making it the most expensive natural disaster in recorded history. Another devastating tsunami hit the Japanese coast in 2011 after a 9.0 magnitude earthquake struck off the coast of Tohoku. The tsunami waves reached heights of up to 40.5 meters, inundating coastal areas and causing widespread damage. Over 15,800 people were killed or went missing, and the total cost of the disaster was estimated to be over $235 billion, making it the second most expensive natural disaster in recorded history. In 2009, an earthquake and landslide in Samoa and American Samoa caused a small but devastating tsunami that killed over 180 people and caused extensive damage to infrastructure and coastal properties. As you can see, tsunamis can be truly catastrophic events causing massive loss of life and property. That is why it is so important to understand the causes and potential impact of these waves, and to take the necessary precautions to stay safe in the event of a tsunami warning. At the end of the day, it is incredible that we've been able to learn so much about these powerful forces of nature and develop the tools and technology to predict and prepare for them. From satellites that monitor seismic activity in the ocean to early warning systems that alert coastal communities of an impending wave, we have come a long way in our ability to understand and mitigate the risks of tsunamis. Hopefully, this knowledge will help keep coastal communities safe from future tsunamis. Thanks for watching. If you enjoyed this video, please subscribe so you can be notified about future content. And if you want to learn more about the amazing science that happens around us every day, check out the Science Explained playlist. Thanks for watching.